Beautiful. Wonderful. So we're going to get started now. Hey, everyone. Welcome to the Microelectronics Showcase. It's actually one that's kind of near and dear to my heart. As you can see from the picture, that's a Raspberry Pi Zero. And I actually took that picture, which is why, it's a little too grainy for it to be taken by me, but it was taken by me. That's one of my fun hobby projects. So I very much enjoy microelectronics and semiconductors myself. And so I'm really excited to talk about this topic or to, see a lot of presentations on this topic because it's fun. All right, so it's only one session. Right now, we're doing the opening remarks and hello and meet the panel. After this, we are going to have the session that's going to be about an hour, give or take. The goal of this event is to bring more deep tech to market by using an ecosystem, right? So we're going to get into it. Josh is going to present a little bit about our parent company. That being said, the goal is there's a lot of tech out there. And when it comes to the technology that we see, not that much actually makes it into the hands of the people who need it the most. So we're trying to do whatever we can, do our piece to, bring awareness to certain technologies, have it that, people meet each other and actually get to network about it. And hopefully things come of that. So who's in the ecosystem? It's startups, tech scouts, both government and corporate, as well as investors. In between, we obviously do matchmaking. So in between the matchmaking, we have these events where companies can present, and folks that are on the event, whether you're on the panel or in the audience, you can connect with the companies. And most companies that present do share their emails. So we're really happy and excited to, make connections where we're able to. In addition to that, we do guided introduction, which I previously mentioned earlier. That are, if you're looking for a direct company, we're always happy to try to put the pieces together and make the connection where we can. So if you see any company on the showcase today and you want to connect with them and you didn't catch the email, we're happy to be the connectors. In addition to that, if you're looking for other deal flow or if you want to collaborate, we're always happy to make introductions whenever we can in order to foster that. The next two showcases are going to be aerospace and defense, as well as advanced materials and advanced manufacturing. So stay tuned. And now we are going to have a little bit of a word from our parent company, Eagle Point Funding. Josh, you're up.
Thank you, Asher, and welcome everyone to the showcase. My name is Josh. I'm a business development manager here at Eagle Point Funding. So for those of you who are not familiar, Eagle Point Funding is a grant writing and consulting company that helps deep tech companies apply to US federal funding grants, whether that's grants and contracts or loans and even procurement contracts. So our goal is to get you from whatever position you're at with your tech to whether that's proof of concept, prototype, to a point where you're going to market and even selling to the government. So how we do this is by working with our clients over a longer engagement, typically 18 months, where we apply to as many relevant opportunities as we can. We're the ones that are finding the opportunities and then taking care of the majority of the application process on your behalf. As well as that, we're also connecting you to members of federal government in our network, which you obviously know, the Deep Tech Showcase. So we help you pitch your tech to a panel of like-minded companies, as well as federal agencies, corporate tech scouts, etc. And yeah, so if you think you have a good innovative tech that's ready to be applying to federal grants, then please jump on a call with me. You can scan the barcode provided there or follow the link. And yeah, I'd love to speak with you about your tech and discuss if there's a good collaboration between yourselves and Eagle Point.
Absolutely. Thank you so much, Josh. And feel free to leave your Calendly link in the chat as well. And with that, we are going to move forward and onwards. So the opening presentation is now. After that, we're going to have RightNet, followed by Rocket Technology Systems, followed by Amber Semiconductors, and Brain CA Technologies. And on that note, what we're going to do now is we're going to go around the panel. And I would like for each panelist to introduce themselves and then also say what focus area their firm, usually focuses in so that, the companies can have a good idea of that. as well as something that you think is going to be the next big thing in semiconductors or microelectronics, if you're willing to share that, right? Some of those might be less inclined, but whatever you're willing to share, we're happy to hear. So with that, let's get started going around the room. Marissa, do you wanna start us off?
Yes, I'm an investor in Silicon Valley, and I have three companies that I'm currently invested in that I think are deep tech. One is Ottava Inc., and they do radio frequency chips. The other one is Terra Circuit Corporation, and they do materials for packaging microelectronics. And then Fireswarm Solutions, which is a drone company. Um, let's see, I've had my recent exits have been Mobalytics, which is a gaming platform, Airbnb, Cyvera, and Temple Automation, and Renovo RX. And of course, I think the next thing is going to be embodied robotics. So I'm looking for, companies, AI companies, because I'm near San Francisco. Okay, thank you.
Perfect. Awesome. It's a pleasure to have you. Next up, we have Samara Curtis.
Hi everyone. Hi Asher. Thank you for having me. Yeah, my name is Samira. I've been in investment the last 5 years. Have done 5 investments, one mini exit so far. Launched my raw lab last year. I'm an acting CEO also of a cybersecurity company right now. Agnostic, honestly, but I'm of course interested much more in a deep tech and a tech general Web3 space as well.
Thank you for joining us, Samira.
Sure.
Next up, we have Jasmine Zhang.
Hi,
Yeah.
Asher.
Howdy.
Great to meet you online again. How are you?
Good to see you. I'm doing
Yeah.
well.
So thank you for inviting me to join this panelist. And so we are the venture team of SK Hynix. As you might be aware, SK Hynix brings memory and storage chips into the semiconductor space. And at the venture team, our investment domain covers data center and infrastructure, thinking of compute, networking, storage, and thermal and power management, and also fabrication solutions. And of course, AI. It is penetrating everywhere. So AI vertical applications in semiconductor space is interesting to us as well. And for the AI, I saw a big trend that for the hardware, NVIDIA and others and us, have already laid the foundation of hardware. And nowadays, I think there's a trend that AI is penetrating into the hardware design or fabrication process. So making the design and production process more efficient and productive. So I'm more looking at this space for a while, and then happy to share more insights with other panelists. Great to meet everybody. Have a good day.
Absolutely. Thank you so much for joining us. Next up, we have Samuel Kim.
Hey everyone, my name is Sam. Can y'all hear me?
Yep, loud and clear.
Okay, great. So I am the managing director of Bandgap Ventures, which is an early stage VC fund out of Austin, Texas. We focus primarily on advanced materials with applications to lots of different industries and verticals. A big part of our investment thesis is to collaborate with corporate venture funds. So every single one of our deals has a corporate VC on the cap table. And we've done deals with, the likes of Intel Capital, Applied Materials, Merck, the energy companies like Conoco, Chevron, BP, and Shell. One of our best investments has been a semiconductor photoresist company called Impria Corporation out of Oregon State University that got acquired by JSR for $514 million. Another one of our favorites is an electronic materials company called Electron Inks, which is also based out of Austin. They do a lot of conductive materials for semiconductor packaging, One of the co-investors for that is Advanced Semiconductor Engineering out of Taiwan, one of the largest chip packaging companies in the world. And recently I took a new position with Texas A&M University as the managing director of new ventures, which covers, and that's a system level position. So it covers 11 institutions and 8 state agencies across the state of Texas. We've invested a lot of money into something called the RELIS campus, which is kind of a proving grounds for a lot of deep tech. So Asher, we need to talk more about defense and aerospace because we've got a lot of capabilities and facilities there. But for semiconductor, we just started a new semiconductor research institute. And we're having some front end manufacturers as well as we're trying to get ASC engaged into that so we get some back end. And so we'll kind of have a total solution package there on the campus. So we're looking for industry engagement with all the assets that we have at A&M. And, we've got like $10 billion of assets. So we're looking for startups to come and engage with our, resources, capabilities, faculty expertise, sponsored research, et cetera, but also with corporate investment partners that want to leverage all the investments that state of Texas and Texas A&M has done. Next big thing, I think, is obviously AI, but all the ancillary kind of verticals that are related to AI that can benefit from it. I was just looking at the new NVCA report that just came out for Q1 of 2025. 71% of VC capital was in AI companies. And so clearly there's a lot of interest there. I think that A&M has a really good is well positioned to use AI that's applied to different verticals like agriculture. A&M is one of the top agriculture schools in the country. We were also actually #1 in engineering R&D expenditures. We're also, have a lot of investments in life sciences, robotics, automation, autonomous vehicles, and we have 4 nuclear reactor companies coming to RELIS. Small modular reactors. So all the things that will power and enable AI in the future. So I think I've spoken too long. I'll let everyone else speak. Thanks.
That's awesome. No, that's really cool. So I'm sure there's going to be some interesting collaborations there. We need to talk more. Next up, Mike Telside. Mike, go right ahead.
Hey, good morning, everyone. Mike Telside here. I'm currently an officer in the Space Force. My job is the Deputy Branch Chief for Mission Protection for all the space sensing satellites or constellation. So I do basically missile warning, missile defense. So I must preface that I am not representing the government here. I've held multiple positions, including running a international accelerator, where I was helping startup get government contract and facilitating connection. So that said, I'm no longer doing that job, but I am still plugged in and I still believe in the mission. So I'm here seeing if there's anything that I can see applicable to the military or make a connection. So I'm here for that.
Awesome.
So for the next big thing, again, I know people already said it, it's AI and especially robotic, but I must emphasize the dual use as you go out there and building companies. Think of, the government has different requirements. So if you are looking for this government contract, think of dual use as you start building. Thanks for having me.
Absolutely. Pleasure to have you. All right, Gerald Wang, you're up.
Yeah, hi everyone. I'm Gerald Wang. I'm from GC Ventures. So my firm is a corporate venture of a Thailand-based petrochemical company called PTT GC. In short, it's GC. So for GC, we are very into the polymer related innovation for semiconductor and for consumer electronics. So we made 13 investment to startups, 7 investment to funds so far. 3 of our portfolio companies are working on semiconductor industry. One of the Agnanos, waterproof coating for PCB, and Boston Materials is a thermal interface materials. Another is phase change material. Another one in thermal management side. So we keep looking at this field and would like to collaborate and invest into more companies into this field, because as many other panelists already mentioned, that this is a big thing in this century. So we would like to ride on the wave and serve the world with higher computing power and a more efficient AI.
Awesome. Thank you for joining us, Gerald. Next up, Sergey.
Hello, everyone. My name is Sergey. I'm with TIL Venture Capital. We are the corporate venture fund of Tokyo Electron Limited, TEL, which is one of the 4 largest semiconductor wafer fabrication equipment suppliers to the semiconductor industry, alongside companies such as Lam Research or Applied Materials, which are also well known. Our focus as the corporate venture fund is to find technologies that will help make the equipment of the future for the next generation semiconductor material technologies manufacturing. So it's very deep tech and hard tech focused, and there's always we're looking for synergies with our core businesses. In terms of the next big thing, I think it's very much going to be about enabling AI on the hardware side, be it improving power efficiency from optical communication standpoint to overcome the memory wall and other problems that are connected with more AI consumption. So I think there's some startups here that will speak more to that in the future. Thanks.
Thank you. Thank you so much, Sergey. All right. And with that, we can begin the presentations. Thank you to all our panelists for joining. I'm excited to have you, and I'm excited to hear some interesting questions and interesting comments. We're going to start off with RightNet, and you can begin sharing whenever you are ready.
Can you guys see the screen?
We can see it, but it's not on presentation mode yet. Or at least the one we see is not yet on presentation mode.
Oh, hold on 1 second.
It's down.
It's down
Sorry.
on the right side,
That's just down on the right side.
and just reverse your screen.
Is
We're
that
looking at your side of it.
can you see the screen now?
But if you want to switch it, because right now it's on the presenter view. If you
Yeah.
hit the top on the top left side of your screen, there's use slideshow. Yeah, just play from the start. Sure, go for it.
Let me start. Yeah.
Yep.
Sorry, I'm not that expert on platform presentation. Sorry.
Go for it. Just yeah. Okay, perfect. We see it.
Good. Yeah, my name is Annamalai Ramanathan. I'm the president and CEO of RightNet Corporation. We have been in business for more than 25 years, serving various government agencies. Our expertise is mainly satellite, IT, and cloud. Today, I'm going to present some novel solution or a new solution for satellite communication. If you look at the problem today, in most of the satellite connections, let's say when you're flying or when you have a UAV or you have anything else that's connected to the satellite, it is prone for weather-related issues or some satellite link not being reliable, then the entire satellite connection that you've been communicating is gone. So that's why we propose a product called Smart Link or software defined. It's like an SDN, software defined network, but this is for satellite. We call it the Smart Link operator. What is that? This is nothing but a smart router connecting your satellite connection to various satellites at the same time. So if you have connection issues with satellite A, it will automatically detect the quality of the link and switch it over to satellite B. So you have multiple connections. So basically, you're always connected in that scenario. So what is an SLO? It's a smart defined router, monitors the satellite link quality, detects any slow or dropped satellite connections, and it will automatically switch to a better route and ensures you have reliable communications all the time. So why do we need this? I talked about the problem, but then why do we need it and who needs it? If you look at it, like I mentioned earlier, satellite link is not like your fiber connection. So it can drop more frequently. So in that case, then let's say you have a UAV in a contested location. What happens if the satellite link goes down? Now the UAV is out of communication with anything that's important to be communicated, then you've lost that few minutes of satellite connection. So what do you do? In the olden days, people used to manually switch them. In the UAV, you don't have the space for a human being to sit inside and switch the connection to a different satellite. Even in the ground, if you have people switching the satellite connection from A to B, it is time consuming. So that's why it really matters. So what are the key features of this? The product that we propose is the real-time monitoring of your link, and we have decision making based on some AI. So it learns as it goes. So it knows which quality link is good, which quality is bad. So, and then it can make real-time decision. And the best thing is you can integrate this product with any of the existing modems that's out there. So we'll use standard protocols. So what are the use cases that we think it could be useful? Like I mentioned, UAV, Space Force, military, and maritime, and for disaster recovery. Those are some of the use cases we think it would be very useful because those are very critical depending on the satellite connection. It depends on it. And also it could be used for commercial purposes. If you look at any maritime or airlines where they're trying to sell internet connection on your flight, so it could be useful. And media companies that's going into remote location broadcasting your, let's say, NFL, Super Bowl. So those are some of the things that we think. And then oil and gas, agriculture, some of these areas where the satellite reliability is important, so they could use it. So why do we think it's important for the commercial side? Let's say you lose the connection for like 10 minutes. Look at the lost revenue for that. So this won't even cost that much. So it's a lot easier for you to put that into your network and include that into your reliable communication link. So we talked about how it works, so I don't need to repeat it. So this is at the high level. So you have the routing engine, and then it's connected to the satellite modem, and it uses various technique to detect the quality of the link connection, and it can make that decision. So there's a decision engine in it. Here's an example of UAV connected to multiple birds. So that way, when the link goes bad, it can connect to a different bird, and then it can continue to do the mission critical work that it's been doing. If you look at today's current systems, they can't adapt, they only can react. And if you want to change into a different vendor, it's not that easy because you're already tied to the modem and to the satellite. With the hybrid approach that we have, you'll be able to switch without any issues. So here are some of the benefits that we think are useful for the commercial as well as for the government entities. Why RightNet to do this? We have been working with the satellite for almost since 1988, sorry. So we have a history of working with a lot of satellite providers, the modem providers, so we know. And we have people who have PhD in satellite engineering and telemetry. So we have the skill sets to do it. And we know what the government process looks like. And we also work with a lot of the commercial vendors. So we also know the commercial side of things, how things are made and how things are important for them. So we have that skill set. So what are we looking? Obviously, if we get some funding, it would expedite the process to completion, and it will give us a chance to integrate our product with a pilot project where we can test out some of the thesis and some hypotheses that we have and fine tune some of the things that's needed. And also working with the potential customers and some funding, it gives validation to the product.
30-second warning.
Yes, okay. So that's pretty much, that's what we're looking for. Sorry. Any questions?
Perfect. Okay, let's open up the floor for questions. What we'll do is you could either chime in or there's a react button on Zoom and you could raise hand with the react button. It's a little more organized if we use the button, but also happy for just chime in. Feel free to go right ahead.
All right, I'll go. Again, Mike Telside. I work with satellites. So how will you deliver the service? So I'm imagining a UAV, something that relies on net connection.
Yeah.
We'll have a built-in
box.
way of searching. So it's a box that will
So
enable
much-
them to do that.
Yeah, it would
right?
be like, it would be very similar to, it would be a lightweight, sort of no bigger than a 1U chassis box that has all the software that's needed. That will be connected to multiple modems. And each of the modems are connected to different satellite birds. So our box is going to be lightweight, no more than 1U for the UAVs or less than that.
Okay. My next question is about security. You say your target is government, and you also say you're using standard protocol. How do you approach the security of data going through your router?
So the data, we have built-in security so that, you know, people won't be able to tamper our boxes, but the modems have a built-in encryption also included. So that way, any traffic that goes through our box will also be encrypted, so it won't be hacked.
All right, thank you.
Yeah.
Marissa, did you want to ask a question?
Okay.
Marissa, go right ahead.
So you are satellite agnostic, right? So
Yes.
who are some of your commercial customers?
For the satellite, commercial customers are pretty much our broadcasting companies.
Okay. Can you name
There are
any
some vendors
specific
who
ones?
work with the broadcasters, so we work with them also.
Okay. And then, so do you have any names of?
So we used to work with a company called Encompass Digital. And we also work with Fox, CBS, NBC.
Okay.
Any questions? So Fox and NBC, we work with them to gather a lot of the data, and we also work with the government on the other side also. So we get their data ingested, processed through our satellite network, and then distributed to the government end users. And
So
if
you've been around for 35 years, right? Yes.
1988, yes.
Okay, so aren't most of the big satellite companies, don't they have something like this already installed?
No,
So they
that's a
can
good question.
switch?
No, that's a good question. As of now, they don't have it.
Oh,
They are manually switching it over. The satellite providers. If you notice, since you're in California, you know this SDN, software-defined network, that been getting very popular on the land side. It took a long time for people to realize the benefit of it. Only now it's getting deployed all over, right? It's very similar to SD-WAN, but SD-WAN, if you look at the technology behind it, it has the knowledge for the telemetry for the LAN and fiber and so forth. So it knows when the quality of the link is bad for a fiber, it knows. For a coax cable, it knows. But for satellite link, they don't know it. That's why you can't plug that SD-WAN box into this and say switch it over to a different network. So it requires a different skill sets.
Okay, thank you.
Did I answer your question?
Yes, you did.
Perfect. Thank you so much for the presentation.
Thank
That's the time we have. Feel free to leave your contact information in the chat, and I'm
Yes.
sure yeah, some folks will reach out. Thank you so much for that presentation. All right, next up we have Rocket Technology Systems, and presenting will be Jeff, I believe.
That is correct.
Good. You
All
just have
right.
to put it on presentation mode. There you go.
All right. Dr. Jeff Wallace, Rocket Technology Systems, defense electronics startup. Among other things, we're pioneering secure AI-enabled microelectronics, foundations for next-generation defense, aerospace, extreme environments, and enterprise infrastructure. Our problem space is the Defense Department's secure networks are old and costly, and they really can't handle today's complex needs. You know, we hear a lot about AI in the military, but the latency needs to get at least a factor of 10 better to be able to do this over and be secure the way they want. And hardened processors are also outdated and expensive, very expensive. And due to the methodology, they take up 3 times more swap than they really need to going forward. And there's no really good option for secure mobile or edge computing. And civilian systems are even worse off and getting worse all the time. Now, just to kind of focus our minds here, kind of one of our big sample problems is F-35 swap C reduction. You look at having 10 separate radio and sensor systems highlighted in yellow here. And our vision is to consolidate those into 2 software-defined radios that use a handful of these chips. And so our product line here is secure RISC-V based system-on-a-chip designs that revolutionize classified networking and computing, with product lines for extreme environments, meaning advanced materials and pushing advanced materials more. We've already built an MVP SoC that is on a functional motherboard, which is important for OEMs, and we are actually ready to take orders now. Now, this methodology is 10 times faster than current SIPRNet, that means secret networks, and comes with much lower size, weight, and power requirements. Now, this is a huge market, and I would say that 33 billion is really a low estimate. 9 billion in defense cybersecurity, another 6 billion for civilian infrastructure, another 15 billion for corporate IT and security, and raising the game in the same way in corporate as well as the government, and 3 billion in engineering and manufacturing protections. Well, progress to date. In the best spirit of Qualcomm, filed 8 foundational patents that have to do with things like cryptography and the instruction pipeline and new materials science. We built the MVP, and we also have designed the next generation multi-enclave agile crypto SoC that is ready for tape out across 3 configurations, small chips for IoT and low swap C situation, mid-size chips for PCs and workstations, large chips for enterprise computing, and we have done not just extensive market research, but also outreach, talking to real customers and suppliers that are very excited and think that people will be receptive to a RISC-V competitor. And the bottom line here is we're ready to take orders on day one, and we feel like customers are waiting both in government and private sector. In terms of the execution details here. We're seeking seed funding to start filling orders and prepare for Series A to scale. And we want to take this to people that are interested. And our team is led by the only person who's ever certified a mobile multi-enclave system with the NSA. And that really is important when you're talking about fancy security. We're partnering with Sci-Fi, Global Foundries, and Marvell for manufacturing. And, you know, we feel like our financials are conservative. We expect positive cash flow in 24 months and break even in 30. And the demand really is huge, we feel. The Fortune Global 1000 companies and governments worldwide really need these chips. And once again, we've done some real boots on the ground outreach here, even to a number of countries around in the Gulf states. In addition, just in South America as well. And, you know, these are used, you'd be surprised how many chips are in rockets, satellites, planes, ships, and robots. In addition to the corporate IT. And that's our, you know, story in a nutshell with respect to all of this. We are, you know, actually do a number of different defense electronics things and communications and really focused around software-defined radios. And this is sort of a situation where if you want the job done right, getting in there and doing it yourself. Some of our government colleagues, you know, gave us a push to go and try to take this seriously, and so we have. And so I'd like to say thank you for giving us your time here, and be happy to answer any questions if I can.
Sure. Thank you so much, Jeff. Feel free to start asking whenever you guys are ready for the panel.
Can I clarify what you see as your competition? Is it other manufacturers of semiconductors that have, for example, like physical and clonable functions, or is it something else?
I would say that it is, it's in two ways. It is the programs that are getting by with what I would call commercial SOCs made by, you know, people like AMD and Intel, and the specialists that are providing these $100,000 per chip assemblies. And actually, some of one of our partners is one of those companies, Marvell, and they realize that you know, that there's a better future to be had for everybody, because you just can't keep pushing these relatively primitive hardened processors out there and really be able to get the job done.
Thanks. And just my second question and last one, what is the technology process node you're developing your chips for right now?
Well, you know, for military, it really doesn't, you know, they are in such a bad way that 7 nanometer is good enough, you know, to really push the ball forward here. We feel like that's a good spot at the moment because we want to take the time to develop the radiation hardening capability where you're actually, I'm going to reveal a little bit here just to pique your interest, where you actually go and take one step beyond the gate all around approach and actually do shielding at the individual transistor level. And then and that's kind of one dimension of complexity. The other dimension is the idea of using advanced materials like lab-grown diamond, silicon carbide, and really start getting serious about two-dimensional substrates like graphene, and pushing that envelope. And so the idea of hearing people that are interested in and have places to work on advanced materials is music to our ears. Does that answer your question?
Yes, thank you.
We have time for.
Yeah.
Go for it, Mike.
Sorry, I can't use the hand
You're
raise.
good.
I don't see where it is. So on the government side, Jeff, who did you conduct your market research with?
Yes, well, that's very interesting. We were actually, we had outreach from the NAVWAR information systems people at Charleston. They're the ones that really pushed us into the game. DISA is a big proponent here. They backed us in a big OTA bid that was to get some CHIPS funding that was overridden by the powers that be. So we really and that's what that really is what pushed us over into working on this seriously. Some NSA people came along and really said, "Wow, you know, if you put this in some of your 5G handsets, because we're also the 5G government people and things like that, that they'd really like to see that." So we feel like we have a good place to start selling systems with the basic motherboards even.
Great, thanks.
All right, perfect. Marissa, go right ahead. I think you're the last question for this. I think you're muted, Marissa. Let's see. There you go.
Is Mark Andreessen your first funding at the seed level?
No, we don't. I'm saying that I want to take our Series A to Mr. Andreessen. We have a long history from back. I actually, as a government employee, way back in 1991 and 2, gave his lab at the University of Illinois their first real funding, and you know, set him on his way. And I've never had a big enough or a good enough idea to go take in front of him at the same time that he had interest in the defense market, and so that's why I call out. Mark there.
Okay, and the second question, I always ask this for people that have MVPs. Do you have any beta users?
So, well, we actually have built a set of these 5G Wi-Fi hotspots that we are getting ready to put out into beta testing. Yes. Both actually in the private sector and over on the government side. Over on the government side, we're gearing up for a big Vice President Vance, you know, supposedly attended event at Virginia Tech in the fall, and that is kind of an extension of this OUSD 5G contract that we had. And then, interestingly enough, I don't know if you're a soccer fan, but a guy named Neymar, famous soccer player, is behind a development company in Brazil. I have a vacation home or retirement home in Brazil, and so we're starting a pilot with a development group that is backed by Neymar in a huge smart city, a 75,000 person smart city development in Brazil, and using these 5G enabled hotspots with the secure computing. And, you know, we have some actual Brazilian Air Force interest in what it is that we're doing here as well. Oh, and the Kingdom of Saudi Arabia. So I'm sorry, I forgot about that. And smart cities.
You're good. Awesome. Thank you so much, Jeff. That was a fantastic presentation. Feel free to leave some of your contact information in the chat so people could reach out. And yeah, that was fantastic. Next up, we have Amber Semiconductors. Presenting will be Thar. Whenever you're ready.
Asher. Can you hear me?
Yep, loud and clear.
Awesome. Thank you, everyone. Thank you. Good morning. My name is Thar Casey. I am the president and CEO of Amber Semi. I'm also the founder of Amber Semi. Let me start sharing my screen. And do you guys see it?
Not yet.
Not yet. Let's try again.
There you go.
Okay, awesome. So Amber Semi is a fabless semiconductor company in Silicon Valley. Our focus is to go after power and energy. inside data centers predominantly, and everywhere, and every building, and in every factory. We came up with some very disruptive technological breakthroughs that allows us to turn electromechanical solutions to solid state solutions. But let's focus today on the semiconductor solutions inside the racks and inside data centers. I'm sure that most of you know that 3% of the current power that is being generated in the United States is going to data centers, and expected, that's in the United States, and expected to hit way over 8% by 2030. That's not new. We all know this. Therefore, the hyperscalers are not going to rely on the grid anymore, so they're focusing on bringing their own power solutions to their own data centers. Now, we are not focusing here, however, we are focusing inside the data center itself. If we were to take it all the way from the source to the AI chip, to the GPU, you will see here in the blank white is the building, and inside here is the rack. And if we were to take it from the source all the way to the GPU, there is lots of step downs in electricity. That is 480 volts AC to 240 AC, then it goes inside the rack, then it goes from 240 to 50, 50 to 12, 12 to the motherboard, and then from the motherboard goes to the GPU at a 0.8 volts. Very inefficient. We lose 23% inside the building without even hitting the rack yet. And then we lose an additional 20% inside the rack. That is not even adding in here the losses on the motherboard itself. Amber is coming up with two solutions. We're going to eliminate all of these different step downs, and we are going to bring it into two steps, all the way from 800 volts DC to 50 volts DC. And then we take it from 50 volts DC directly to the AI chip, to the motherboard. By doing such, we will bring as much as 90+% inside the rack and 90% plus outside the rack. We will cut the losses inside the data center in half. Each 1% in the United States alone represents $500 million of savings. That's about $4.7 billion in savings on only 9% improvements. It's substantial. Most of you probably know what Moore's Law is. If you take a look at the NVIDIA GPU, or actually their processor from back in 2017, it was only about 350 watts of power. Now we're looking at in 2024, they're about close to about 1,200 watts of power at 0.8 volts. That represents about 1,500 amps of power. By increasing the amount of power requirements, the transistors around it to bring power to the GPU, it has also increased. Therefore, there is a bottleneck on the motherboard, a major bottleneck. While all these industries and all of these AI companies are coming up with new solutions, it doesn't get solved at all unless we solve the problem on the motherboard powering up the AI chip. Because at the end of the day, if something can be processed, let's say a very complex model in, let's say, 10 minutes, unless you're going to turn it into and to bring more power to the AI chip to turn it into a 1 minute, you can't do it. So therefore, in order for us to make that processing time faster, we need more power to the actual AI chip, to the GPU, CPU. Well, this is the latest. This was just announced by NVIDIA. The B300 Blackwell Ultra is about 1,750 amps of power, which we know that, at a 0.8 volts. And now the Rubin Ultra, which will be released in 2027, 4,500 amps of power. It won't work unless you're going to change the architecture of the motherboard. And I'll show you why. This is what the Blackwell motherboard and the rack looks like. The circle that you see here is actually the 50 volts to the 12 volts. Then you see a set of fans over here for the cooling. That's in addition to the liquid cooling plates that goes on top of the motherboard and the GPUs. Then you see those red bars. Those are the 12 volts bus bars coming into the motherboard to power up the motherboard at 12 volts. But the GPU, it requires 0.8 volts. So this is a GPU, two GPUs, two CPUs, and memory and power. That's it. That's what you see here in front of you. Let's zoom in a little bit. This is what a GPU, this is what an AI chip looks like. This is where all these AI companies who are not coming up with an actual chip, that's where they live eventually. They need to process faster. 69 phases, bringing it from 12 volts to the 0.8. Each phase, it has 3 silicon in it. The power losses within this 67 millimeters, it's almost equal to the power losses that you have inside the rack itself. It's substantial, only in that small distance through the tracing. So what happens in this case if you want to go to, let's say, 3,000 amps? Photoshop this just to show what it looks like. Well, I square R will not going to allow you to bring that much more power to the GPU or CPU without having substantial amount of losses. It will be as much as 8 times more losses if we were to go from the center of the power to the center of the chip.
30-second warning.
The only way to do this is by going from underneath the solution itself, going underneath the chip. Our solution, it will be 1 millimeter only, and it will sit right underneath the GPU, CPU. Our technology is scalable. We can be 200 amps or up to 5,000 amps. We can be on top of the board or underneath it. Same solutions, it can go into the automotive, and we're building it with TSMC. We are a fabless semiconductor company in Silicon Valley. We've raised $33 million. Our solutions is being launched at the end of this year, and different technologies and different products. We have design wins, and we have many customers. We are building our data center solutions right now based on the requirements that we have received from AI companies. 49 granted patents, multiple awards, and we are raising our third round of financing. We're looking at $30 million from VCs or CVCs, and we're also doing a convertible note for time being.
All right. Samira, you want to go right ahead?
Yes, quick question. Yes, you're on Series B, right? So I already checked it, you guys were just, what is your ARR? So how much money are you making at this moment?
Right now, this year will be our first year for revenue. And we're looking at the latter part of this year will be somewhere around $5 million.
That's how your pipeline says? Or
I'm sorry?
that's your pipeline?
That is a combination of NRE, pipeline, and some engagements, if you will, that we have.
How big is your sales team at this moment?
Right now, we have a small sales team because we're a fabless semiconductor, and we're focusing purely on our alpha customers. We're not opening up the floodgate. If we open up the floodgates, our sales will be substantially more than that. But in silicon, you want to make sure that you're mature a little bit and you work only with your alpha customers.
So you have no worries about the market deployment? Because that's something what I'm actually thinking about, the market deployment, what your strategy is on that. But we can kick this offline. That's okay.
Sure.
Thank you.
You bet.
Perfect.
Any other questions?
Yeah, we got time for one more. Sergey, go right ahead. So yeah.
Sorry, thank you for the presentation. Great
Thank you,
stuff as always. Do you have a minute to talk about the other industrial applications beyond what you've mentioned so far?
Sure, of course. We came up with solid state electrification. We eliminated, in this case, the electromechanical solutions, and we brought solid state. That means we're eliminating, in this case, the electromechanical PDUs for automotive or electromechanical PDUs for data centers. We are eliminating the circuit breakers for factories and oil refinery, aerospace, military. We are bringing chip. As a matter of fact, we brought in the world's first chip that lives on AC. We take the electrical sine wave, we manipulate it, chop it, dice it, we do anything we want to do with it, and then we turn it to DC or whatever we want to do with it. There is no chip lives on AC. We're the only one. And we're eliminating the power supplies that converts AC to DC with a tiny chip. And there's a lot more to Amber than just what I shared with you. We leverage what we have, and we're taking it to the data center because there's an immediate need, and we focused on this in addition to what we are actually have the design wins and the engagements and the customers.
Thank you.
Thank you, Cesar.
Absolutely. Well, thank you so much. If there's,
Thank you, Asher.
yeah, thank you for joining, and yeah, feel free to leave your contact information in the chat. I know that you're going to set something up with Samara. Next up, we have Brain CA Technologies. Feel free to start sharing whenever you're ready.
Great, thanks, Asher. Let's see, the Deep Tech Showcase folks have or will distribute our pitch deck.
Yep.
So rather than slide whip you, I just want to take a few minutes to tell you what Brain CA is all about, and you can refer to that deck if this sounds interesting to you. Now, clearly, AI has taken off, and the cost to get more and more sophisticated capabilities is skyrocketing. And this can be directly traced back to the massive computational requirements needed to train and operate today's models. And those requirements are straining several very challenging limits of the conventional processors that are carrying the load these days. And meanwhile, it's evident that these conventional approaches are just multiples of orders of magnitude away from the efficiencies of biological brains. As just one example, a mosquito's brain is like 40,000 times smaller than an NVIDIA H100 chip, and has almost 400,000 times fewer components, and has 700 million, I'm sorry, uses 700 million times less energy. And yet it's able to manage all of its bodily functions, circulatory, respiratory, and so forth. It can navigate in 3 space. It can remember, where its nest is. It can remember where food is. It has all kinds of defensive mechanisms built in. Clearly, it is dramatically more efficient. And at Brain CA, we've developed a new microprocessor architecture to put AI on a new trajectory of performance and efficiency that's much more comparable to biology. And what we did was we went back to first principles regarding learning systems, and we developed a new approach, a new architecture. And rather than go down the conventional path of using conventional, complex mathematical curve fitting to simulate intelligence, we developed and we got some very broad patents on some key innovations that enable learning by observation of data relationships in a spatial temporal architecture. Now, the root of that approach is a branch of computer science originally explored by John von Neumann called cellular automata, and hence the CA part of our name. It's a massively parallel approach that uses large quantities of very simple autonomous cells with very simple rules, and they're able to produce just beautiful, elegant sophistication and learn. And so some of you may be aware of Conway's Game of Life, which was kind of an early implementation of all this. And the simplicity of those cells allow us to use very much fewer components, very far fewer components, in a much simpler configuration than conventional chips. And that makes it easier for us to manufacture and much less expensive to manufacture. And more importantly, it uses much, much less energy. And so what we did was raised $2.2 million in some seed money and set to work. And we first advanced our designs from an initial theory to software simulations of very simple logic gates, which proved the basic functionality. And then we enhanced those simulations to solve some simple categorization problems, moving from a 7-bit model to a 20-bit model to an 81-bit model and so forth. And we're now moving part of that simulation, that software simulation, to silicon. FPGAs to be precise, that will allow us to get faster performance as we're exercising and tuning the systems. And we've also qualified for a program called Lab to Fab that will help us to very economically create custom silicon from our designs. And we've also signed up for and are participating in startup programs at NVIDIA, Intel, and Google. But what we're really finding exciting is that this technology scales downwards very nicely. We're particularly excited about applications for the edge where energy and weight and size are critical. And there's an enormous opportunity in IoT that will leverage our strengths by going where traditional AI and those processors just simply cannot go. So along that line, we're entering into agreements with some industry partners that have applications that would benefit from energy efficient, scalable solutions. And we're using those discussions to better understand their needs and the applications and to kind of guide us in our design decisions as we're building this out. And we're really proud to have been invited for the second year in a row to present 2 different papers on our technology at the International Symposium on Computer Architecture. Last year it was in Buenos Aires, and this year will be in Tokyo. And there's been substantial interest in our work, and our team is literally writing the book in this new area of computer science. Along that line here, I wanted to share here that if you are interested in learning more about what's under the covers, we just published a book called The Intelligent Shift that's now available on Amazon that goes into a little bit greater detail. It's not written, super technical, and it's a pretty quick read that definitely explains, our approach and the elements that make it up and build into an intelligent learning system. So what we're doing at this point is developing connections to academia so that we can get our processes and our technology peer reviewed and develop additional credibility in that respect. And we're also talking with potential investors that are interested in helping us to accelerate the process of bringing this to market and commercializing it. And I think at this point, I would be happy to take any questions that you all have.
Opening the floor. If anyone wants to go and be first.
I have a question for Steve.
Sure, go for it.
What is your product in the development stage? Is it ready and built into a server or some product it's ready to be used?
It is not ready for use. We are definitely pre-revenue at this point.
Okay.
We are in the process of developing our first implementations in silicon, and as I mentioned, they'll be with using FPGAs. That'll both help the speed with which we can do our tuning, but it'll also be our first implementations that we could literally put into production.
Since you mentioned it's lightweight and it could be used on a lightweight box and also less power consumption, I don't know if you heard my presentation. We were talking about smart link optimizer or a router for the satellite. We could definitely use your product when it's ready because we always looking for we want to put it into UAV or any mobile platform where it doesn't require a lot of power. That would come in handy for us.
Outstanding, and I'm finding many of the kinds of situations that you're in where our technology should be beneficial, and I'd love to connect with you to set up a collaboration agreement where we could kind of whiteboard that and explore.
Yes, we want to be able to install some server like a Linux Lightskin and then put our software on top of it, which will monitor the telemetry data, and then we can do auto routing. So we can talk about it. I've sent my info on the chat box.
Excellent. Thank you.
Thank you. I mean,
Perfect.
our combination product could be very useful for Mike since he's in the Space Force. He understands the sensitivity of the satellite connection, so he can appreciate it.
Yeah, not only that, but size, energy, and weight.
Yes, exactly. Yeah.
Sergey, you want to ask a question?
Yes, Steve, you mentioned that your technology mimics brain. I wanted to ask, are you planning to use some kind of analog compute, in-memory compute, neuromorphic compute technology in your ASICs when you get to them?
Actually, we are not planning to use neuromorphic. This is a different architecture altogether. And so it will leverage and take advantage of some of those things, but it's really a different trajectory altogether.
And in-memory compute or any of the others?
Actually, the cells that we're talking about we're estimating that they're about on the order of 12,000 transistors or fewer, maybe 10,000 transistors. And we can, with that kind of scale, we can replicate, literally millions or billions of these on a wafer. And so that each cell will have its own persistent memory and some transient memory for signals that are traversing the network. So it's not really in-memory compute. It's a highly parallel architecture that's natively sharing information between the processors, and with each cell being a processor of sorts.
Got it. Thank you.
I think that's all the time we have. But thank you so much.
I did notice a question in the chat,
Sure.
a couple of
Go
them.
for it.
Let's see, one was regarding fuzzy logic, and definitely doesn't supersede. In fact, we think there are some interesting things that might leverage one from the other, but we're in the process of exploring that. So I think that's going to be an interesting tributary that we can do some research on. And again, one of the things we'd be interested to do is collaborate with academia or industry to explore some of those. And then the second question I saw there was that, basically all of our initial founding team have our roots at HP. We all met at HP and worked there together for many years. The origin of the architecture was actually the brainchild of my founding partner, Jerry Felix. He had actually put his initial notes to paper in 1991, has been slowly working on that as he ran another business. And when he finally sold that at the beginning of COVID, he had time to focus and literally came up with a couple of the key breakthroughs that made all this possible.
Awesome. Thank you so much, Steve. Thank you for that presentation, and we'll send out the slides. And thank you to everyone who joined. That is all the presentations we have today. So we really appreciate the companies and the panelists for joining us today. And anyone who wants to be connected, feel free to reach out or to do the outreach, because the emails are all in the chat, hopefully. And I really appreciate it. And I'm looking forward to seeing you guys next month at the Aerospace and Defense event. Have a good rest of your day, everyone.
Thank you very much.
Yep, absolutely. Yeah. Bye now.